So then I took the Homebuilt turbine and I ratchet strapped it to a cinder block. No, seriously. All right, guys, so I had to do a little bit more design work, so I went off camera and did a couple other things. Now, if you've been following along and you understand internal combustion engines and you understand that all you really need is fuel, air, and spark, then you've probably been wondering, where the hell am I going to get the air from? And the answer is right through the backing plate. So I drilled, I don't know, 40 or more holes in this thing, all 5/16. The total airflow of those holes, or that is to say the total area, is about 4 square inches, which is exactly the same as our 58 millimeter inducer, or really close. Because remember, you want whatever flow you can get through the front of the cover into the pressure area and then through the flame tube. So we have accommodated that. We have about 4 square inches of area in the flame tube, 4 square inches through the backing plate of the bearing housing, and 4 square inches on the inducer. So we should be able to get a lot of airflow through this thing. And these holes go right through the flange, through the backing plate, and then I even clearanced the actual aluminum of the housing in there, and they go all the way around. So a lot of airflow, that'll be good. I also went ahead and sandblasted everything, including the compressor cover. It all looks good. We're almost ready to wrap this thing up, but let's talk about the ignition system real quick. So I went ahead and got this little spark plug. This is an NGK CMR5H. It is very, very small. The threads are 10 millimeter by 1.0. And then I went and got a 10 millimeter by 1.0 nut, actually a couple of them, and I turned it on the lathe down into this little bung. And then I got, I forget what this is, maybe a 9/16 nut or something, and I turned it into a bung also. And the reason why I did this is because if you thread these things together, I'm going to try to do this with one hand. Then they go right in, right there. And the spark plug is right above one of our injection holes. So basically what I'm going to do is I am going to put that inside this, because the whole thing fits in there. And then I'm going to weld it into the outer cover such that it is centered on that hole. And therefore, if you take the spark plug out, this is welded into the outer cover, so it's all airtight. And then the outer cover and the flange will still come off over the combustor and leave everything there. So, yeah, that's the intent. So this and this are not welded together unnecessarily, because that would just be a kind of a pain in the butt. If I ever wanted to change out the flame tube, I would be able to just cut it right here and then take it out. If this thing was welded in there, that would make it, pretty difficult. So I'm going to go ahead and put that together. And then I think what we're going to do is put fuel to this thing and hook up our ignition system and see if we get ignition and, see how much fire we can make. So let's weld it together. Okay, so we have our bung made here. It came out really, really nice. The spark plug is installed in it for now. And what I have to do is align the outside cover to the inside cover. So we already have our hole right down in there, just like I showed you, the bigger hole. We now have the flange on, the flame tube on, the combustion chamber on, and our fittings in. So I know this thing's aligned because it can't move because we made all this stuff so tight. So what I'm going to do is very temporarily put a few welds around the top just to align these two things, take it all back apart, and then I'm going to dot through the big hole onto the outside case. And that is going to show me exactly where I need to drill this thing. So I'm going to go ahead and do that. Drill a 3/4 inch hole through the side of it, and then this bung should slide right through there perfectly fine. We can then just tack weld the bung into the case, and then we can fire this thing off. So let's wrap that up real quick. All right, guys, so there it is. We got our bung just tacked into the case. Obviously, I can finish welding it later. It protrudes through just enough. It really sits right over the rail and right over one of our injectors, so it's a perfect spot. And I got my ignition system wired up. Obviously, it's hacked, but, I got to ground off the case. My coil's grounded. And since this is in the dark, you should be able to see some spark in there. There we go. So I'll just have this on a switch. So all we need to do now is put some fuel to this thing and see if we can get some ignition. All right, guys, so I have now tacked this whole thing together such that the flange and the outer case and the inner case are all one piece now. Now I have to go weld it all the way around down around the flange, weld it all the way around here, take it off, flip it inside out, weld a little bit more on the flame tube to the flange, and then just weld all the way around the spark plug bung, and then grind that down, grind all the welds down. And then, once I do that, it will look like this. Once you grind it down and blend it out. So the top is all done, looks beautiful. The spark plug bung is completely blended in, looks beautiful. I did not do around the base, it's a little bit of a pain in the butt, but I will get in there and I will grind all that down and make it look good. But everything is right in the world. So now the only thing we have to do now, well, not the only thing, but the next thing we have to do is put the wheels back in, so we can start talking about the tail end of this thing. But we are in the home stretch here, so I think we're going to be firing it up soon for good. Okay, so we're all bolted together. We got our wheels installed here. Everything's looking good with that. Now, our next objective is to the best of our abilities, funnel all this exhaust into this turbine wheel. Now, the best way to do that would be to eliminate this heat cap down here that protects the bearings and turn it into a stator ring. And essentially all that would be is have vanes in it that do not move, that direct the air right into this turbine just to get the best efficiency that we can possibly get. For right now, I am not going to do that for a couple reasons. One being it's going to be hard to get airflow down in there anyway. Two being simplicity. So what I did was I just tack welded that thing down, because what would have happened is the old exhaust housing would have centered it. And if you don't have a means to center it, then, you know, it's going to move around. It's going to be a mess in there. So I bought a couple pieces of pipe that I thought would fit this pretty well, because you want to fit it tight. This one does not fit quite over the exducer side of that. This one does fit like perfectly over the exducer side of that. However, the problem with this one is that it fits way too tight. There is no way that I would be able to fixture this thing up and actually get that wheel centered in it and not hitting the housing with the interference fit. However, it did come in very, very handy because it fits perfectly over that cap. So I used it to center the wheel, center the cap, tight against the bearing housing, and just tack weld it in. So let's remove that piece for now. What we need to do is narrow this from like 5.5 inches down to, well, this is 3 inches, right? So the reason why you want to do that is you want to create a high pressure system behind it, so you have high pressure expanding gases going into this turbine so you can capture as much energy as possible. And then you also want to neck it down to get the velocity up. So I have this section of stainless steel formed pipe. It goes from 4-inch to 3-inch, and it fits that pretty well. It's very, very good. So it's not perfect, but it provides enough clearance that I can put this system together and not worry about it. But it also is tight enough that we're going to be capturing the vast amount of energy of the expanding gases. Now, how do we close the gap around here? And that is simple. I cut this ring. That ring is going to go just like that. So what we're going to do is I'm going to leave this on here as a spacer. I'm going to weld the ring down right in the right spot. And then I'm going to draw a line around my, I guess we'll say, reducer here. I'm going to cut it off, and then I will weld the reducer to the ring, and we will have one assembly, and this thing will be essentially done. That'll be our entire burner, fuel system, everything. And the only thing left that we would need in order to run this thing will be a temporary oil system, so I can do some tests. So we're almost there, guys. So I'm just going to tack weld this thing together, and then we're going to be looking at a finished assembly. And there you have it, guys. So we got our plate 100% welded in all the way around. We have our reducer 100% welded in all the way around. It fits the wheel really, really well. It's like right in the center. Everything is right in the world right now. I just got to kind of let this thing cool down, and then I'm going to disassemble everything, do a little bit of clearancing, and then we're just going to have to start talking about oil and fueling so we can set this thing up temporarily and make it run, see if we can make some noises. So let me just do some clearancing here, and then we'll see where we're at. So then I took the Homebuilt turbine and I ratchet strapped it to a cinder block. No, seriously. I ratchet strapped it to a cinder block. Now I just want to go out on a limb here and tell you guys that this was going to be redneck, and I don't see how it could be any more redneck. I mean, we have the twin propane tanks sitting mere inches from the very hot jet engine. We have the oil lines with no clamps on them. We have the ignition system ratchet strapped, actually zip tied, I'm sorry, to the cinder block. We have the PVC plastic oil tank, which works, by the way. We have the Chinese gear pump. Honestly, I have one of these on my RX-7 as a scavenge pump for the turbo system, and it has been bulletproof, so I bought another one for this. You know what's the terrifying thing about all this? I'm pretty sure it might work. So I'm just gonna go ahead and throw on the old safety glasses, and we're gonna see if we can fire this thing up. Okay guys, so obviously it didn't quite run right. It won't sustain itself. I mean, it fires and stuff and it ignites, but it won't sustain itself. So I think there's a couple reasons. Reason number one, I don't have nearly enough fuel. Those small cans just don't have enough volume. And you'll see later why I really wanted to use those, but I did have some concerns that those weren't going to work anyway. So now I have it adapted to use a 5-gallon can. Number two, I'm pretty sure it needs a stator vane. So we're going to go ahead and build a stator vane real quick for it. I'm not going to film that whole thing. I'm just going to show you what it's going to look like when it's done. And then you guys can see that, which will be really cool. And then number three is that I think the combustion chamber is just too short to run really efficiently. But you'll remember I said this. Now, the reason why I did this math myself is because this is a very short combustor. Common knowledge in the world of people who are building jet engines out of turbos is that this thing should be like a foot long. And I agree with that, but most of those people are building the type of external combustion chamber turbo that I did not want to build. I wanted to build an annular combustion turbo, and because of the limitations of the size of the bearing housing, this is essentially what you have to do. I mean, you only have the space between the compressor and the turbine, right? That's all you have to work with. So I pretty much used every little bit of that I possibly could. Back at the beginning of this video, and I've kind of known that was going to be the case. And this is really, you know, just an exercise in what you can do. You know, I haven't seen anyone build an annular turbine, and I knew it would be tough in this format because I can't make it long enough to get full combustion. But I do believe with enough fuel and with a stator vane, we will make this thing run, even if I'm losing some energy because the combustion chamber is so short. So let's build the stator vane. I'll show you what it looks like, and then we're going to run it again. Okay, so for anyone wondering what a stator array or a stator vane is, it is a vane, just like the vane on the turbine, except it is static, i.e. stator, so it doesn't move. And the reason why I think I needed them is because if you look at the shape of this thing, I'm losing some energy where the exhaust is hitting the back side of this and fighting with itself, so it makes it want to go the wrong way. So what I did here was put these vanes in to direct the airflow directly into the turbine wheel. So all the exhaust will come through that stator array, it will go into the turbine wheel, and I will get every bit of energy that I could possibly use. That's all set. Excuse me while I spend the next 5 hours of my life smoothing all this out and making it work right.
It runs.
All right, guys, so it ran. It took a lot more fuel and a lot more airspeed, and it took the stator array, but it ran. It doesn't rev super high. It kind of like idles and sustains itself, and then any more fuel you give it, it literally is just combusting post turbine, so it's not doing anything. But it does run, and that's all that really mattered to me. I had kind of concerns about the efficiency of the thing, but I really just wanted it to run. And that kind of leads me to the last thing here, and that is, why exactly did I go through the effort to make this thing? And it's very, very simple. And that is because I work in the aerospace industry. I do, things with commercial jet engines and stuff. And I'm a mechanical engineer. And someone mentioned to me recently that I haven't done anything to decorate my office. So I literally built this thing as an office decoration. And that means I needed a really, really cool and functional base. And what I've wound up with after putting it all together is this. So there she is, all mounted up. This is like 100% functional assembly, essentially. So we have our oil pump under there. We have our air solenoid for our air starter. We have our LS coil. We have our oil drain. We have a solenoid back there, or a relay that is, to run the pump. We have our positive and negative back here, and I actually have it hooked to the battery, so we'll test it in a second. We have our propane input right there. All the brass fittings and pipes were turned down so they're perfectly smooth and then polished to a mirror finish. Right in the front here is our air starter, so that gets the thing spinning. We have our plug wire and plug, and then we have 4AN fittings for the propane feed and for the oil feed up into the top. So essentially what I have built is a 100% functional desk display jet turbine. And now you guys can see why I wanted to use those little tanks. Originally I had it in my head that I could put tanks under this too and have fuel on board. But now that I look at it, like, by the time I did that, it would have been huge anyway. So I'm kind of glad that didn't work, because it probably would have been a little bit unwieldy. This is kind of like the perfect size. So essentially we can run it with our 3 switches here. We have oil, which is running obviously. We have air, which maybe you can't hear if I shut off the oil. So that's that solenoid clicking on and off. And then we have ignition, which you definitely can't hear. So that's pretty much that, guys. End of project. I'm going to bring it to work, put it on the shelf, and answer questions about it. So that's all I got for you today. We have built a functional jet turbine. We made a display for it and everything. It's going to be pretty cool. And I actually already have a design in my head to do a different style of turbine, which is like the original patent that I show you that has multiple combustors around the outside. And I have a much smaller turbo, which will push less air, which will require less combustion, which means I can have smaller combustors that are less efficient, and it'll still work, and it'll still rev up, and it'll still run. So that'll be way more complex to make than this one was. But I also think it'll be cooler, and it'll look cooler. And I'd like to have both designs as like display items. So maybe eventually we'll do that, but we're going to go ahead and get back to building the Land Cruiser and some of the other car projects. So the next videos you're going to see are definitely going to be on the Land Cruiser. But until then, don't forget to like, comment, subscribe. Tell me what you're thinking. Tell me if you've seen anything like this before. And I'll see you guys next time on RanWhenParked.